Hey everyone, and welcome back to the channel. Have you ever looked up at the sun and wondered what's really going on up there? It's not just a giant, peaceful light bulb in the sky. Our sun is a dynamic, sometimes violent star, and today we're diving into a mind-blowing question. Could the sun's temper tantrums, known as solar flares, actually be shaking our planet to its core and triggering earthquakes? It sounds like science fiction, but let's unpack the science and see what's really happening. So first things first, what exactly is a solar flare? Imagine the sun's surface as a boiling pot of super-hot electrically charged gas called plasma. Its powerful magnetic fields are like giant, tangled rubber bands. Sometimes these magnetic field lines get twisted up, storing immense amounts of energy. When they suddenly snap and realign, they release a colossal burst of radiation and energy out into space. That's a solar flare. These events are incredibly powerful. A single big flare can release the energy of millions of hydrogen bombs all at once. This energy travels across space at the speed of light, reaching Earth in just about 8 minutes. Now let's switch gears and talk about earthquakes. We usually think of earthquakes as a purely geological thing, right? They happen when the tectonic plates that make up Earth's crust grind against each other. Stress builds up along fault lines, and when that stress is released, the ground shakes. It's all happening deep within our planet. So, how could something happening 93 million miles away on the sun possibly influence something deep beneath our feet? That's the million-dollar question that has intrigued scientists for decades. The idea linking the sun and earthquakes isn't new. For over a century, some researchers have noticed intriguing patterns. They've looked at historical data and found that periods of high solar activity, when there are more sunspots and solar flares, sometimes seem to coincide with an increase in major earthquakes around the world. For a long time, this was considered a fringe idea, mostly because there wasn't a clear physical mechanism to connect the two. How does a blast of light and radiation from the sun translate into physical movement of tectonic plates? This is where things get really interesting. Scientists are now exploring a few potential pathways. One of the leading theories involves something called the Piezoelectric Effect. You might have seen this in action without even knowing it. Think of a gas grill lighter that you click. That click squeezes a special crystal, which generates a spark of electricity. That's the piezoelectric effect. Applying mechanical stress creates an electrical charge. But here's the cool part. It works the other way too. This is called the inverse piezoelectric effect. If you apply an electrical field to certain materials, they can actually change shape or vibrate. So, how does this relate to earthquakes? Deep within the Earth's crust, there are rocks like quartz that have piezoelectric properties. The theory goes like this. A powerful solar flare bombards the Earth with a huge amount of electromagnetic radiation. This radiation can penetrate deep into the Earth's crust and interact with these quartz-bearing rocks. The intense electrical field from the solar flare could, through the inverse piezoelectric effect, cause these rocks to expand or contract just a tiny bit. Now, if these rocks are part of a tectonic fault that's already under immense stress, teetering on the edge of slipping, this tiny little push from the sun could be the final straw. It could be the cosmic nudge that triggers the slip, causing an earthquake. Think of it like a game of Jenga. The tower is wobbly, and one block is already under a lot of pressure. You could gently breathe on it and nothing would happen. But if you give it one tiny, precise tap in just the right spot, the whole tower could come crashing down. In this analogy, the stressed tectonic plate is the wobbly Jenga tower, and the energy from the solar flare is that final, critical tap. It's not causing the earthquake from scratch. It's potentially triggering an earthquake that was already going to happen eventually. Another related idea involves something called magnetostriction. It's similar to the piezoelectric effect but involves magnetic fields instead of electric fields. Certain materials will change their shape or size when they are exposed to a magnetic field. When a solar flare erupts, it often sends a cloud of magnetized plasma hurtling towards us, called a coronal mass ejection, or CME. When this CME slams into Earth's magnetic field, it causes a geomagnetic storm. That's what creates the beautiful auroras, the northern and southern lights. But this storm also causes fluctuations in Earth's magnetic field that can penetrate the crust. The theory of magnetostriction suggests these magnetic fluctuations could cause certain rocks in the crust to deform, again adding just enough stress to a primed fault line to set it off. So, we have these plausible theories, but what about the evidence? This is where the debate really heats up. A team of researchers recently published a fascinating study. They analyzed data from the past 2 decades, comparing the timing of major solar flares with the timing of large earthquakes, specifically those with a magnitude of 6.0 or greater. What they found was pretty startling. They discovered a strong correlation, suggesting that major earthquakes were significantly more likely to occur in the days following a powerful solar flare. The data seemed to show a clear spike in seismic activity after the sun threw a tantrum. However, it's crucial to understand that correlation does not equal causation. Just because 2 things happen around the same time doesn't mean one caused the other. It could just be a coincidence. Imagine you notice that every time your local ice cream shop sells more chocolate ice cream, the number of people at the public pool goes up. Does eating chocolate ice cream make people want to swim? Probably not. The more likely explanation is a third factor: hot weather. When it's hot, more people buy ice cream and more people go swimming. Many geologists and seismologists are skeptical for this very reason. They argue that the energy from a solar flare that actually reaches deep into the Earth's crust is incredibly tiny, compared to the colossal forces involved in plate tectonics. The energy built up along a fault line is immense, accumulated over hundreds or thousands of years. They find it hard to believe that the whisper of energy from a solar flare could have any meaningful impact. They argue that the statistical correlations found so far might just be a fluke, or the result of not looking at the data in the right way. The scientific community is currently in a tug-of-war over this topic. On one side, you have scientists pointing to compelling statistical patterns and plausible physical mechanisms like the Piezoelectric Effect. On the other side, you have scientists who demand more direct evidence and point out the massive energy difference between solar events and tectonic forces. Both sides make valid points, and that's what makes science so exciting. It's a process of questioning, testing, and debating until the evidence becomes overwhelming. So, what would it take to settle this debate? We need more data and more sophisticated models. Scientists are working on placing more sensitive magnetometers deep underground to directly measure the electrical and magnetic changes in the crust during a solar storm. If we could directly observe rocks vibrating or deforming in sync with a solar flare right before an earthquake, that would be a smoking gun. Additionally, as our understanding of both the sun and the Earth's interior improves, we can create better computer simulations to test if these cosmic triggers are truly possible. Let's just say for a moment that the connection is real. What would that mean for us? It could be a game changer for earthquake prediction. Right now, predicting the exact time and place of a major earthquake is impossible. We know where the risky areas are, but we don't know when the big one will hit. If we could confirm that powerful solar flares are a reliable trigger, it would give us a potential warning system. Satellites are constantly monitoring the sun. We can see a major solar flare the moment it happens. Since the most energetic particles can take hours, or even a couple of days to reach Earth, this could give us a precious window of time, a heads up to issue alerts for high-risk fault zones around the globe. This wouldn't be a perfect prediction, but it could be an invaluable tool to help authorities prepare and potentially save lives. This entire field of study is a perfect example of how interconnected our universe is. We often think of geology, astronomy, and physics as separate subjects, but here they are, all tangled up in one fascinating mystery. The idea that a storm on a star millions of miles away could shake the very ground beneath our feet is a powerful reminder that we are part of a much larger cosmic system. We're not isolated on our little blue marble. We are constantly being influenced by the forces of the cosmos. So what's the final verdict? Are solar flares triggering earthquakes? The honest answer is, we don't know for sure yet. The evidence is intriguing and points to a possible connection, but it's not yet conclusive. It remains a controversial but incredibly active area of research. What we're witnessing is science in action, a bold hypothesis being rigorously tested from all angles. Whether it turns out to be true or not, The quest to find the answer is pushing our understanding of both our planet and our star to new limits. It's a cosmic detective story, and we're all waiting for the next clue. Thanks so much for joining me on this deep dive into one of science's most exciting questions. What do you think? Is it a cosmic coincidence, or are we on the verge of a huge breakthrough in understanding our planet? Let me know your thoughts in the comments below. And if you enjoyed this journey to the sun and back, don't forget to hit that like button, subscribe to the channel, and ring the bell so you don't miss our next exploration into the wonders of the universe. Until next time, stay curious.